Off the coasts of Newfoundland and Labrador, each spring the icebergs come, carried south by the Labrador Current. Towering, majestic, weighing millions of tons, they move with awesome force, a great hazard to all maritime industries in the waters through which they pass. The dangers are not just those of collision on the surface. For with a volume 10 times greater below than above, some larger bergs actually scour the sea floor, cutting great trenches as they pass. Any subsea oil production system in an iceberg zone would be extremely vulnerable unless a sheltered habitat could be installed below the ice scour line. To develop such a system was the challenge assigned the East Coast Drilling Operations and Engineering Group of Mobil Oil Canada Limited in late 1979. It was a matter of urgency, since significant hydrocarbon deposits had been discovered in the Hibernia P15 well, on the eastern edge of the Grand Banks, 168 nautical miles from St. John's, Newfoundland, right in the middle of an iceberg zone. February 13, 1980. The supply ship OSA Ostend steamed out of St. John's Harbor with numerous pieces of big hole drilling hardware on her deck. Her destination was the Sedco 706, a semi-submersible on charter to Mobil, in position on the Hibernia field. This rig had been chartered because of its large deck space and loading capability. Moreover, it was one of the most stable rigs available, an important consideration in the heavy midwinter weather of the North Atlantic. In fact, weather was the major concern of project personnel who had worked day and night for months to develop the technique that they were now about to test. Yet the urgency of getting on with the job, combined with rig availability, left no choice. They must proceed. The location selected for this step-out well, B08, was about 3 miles from the original Hibernia discovery well, P15. Once the rig was positioned and a core sample taken, a pilot hole would be drilled to a depth of 45 feet, using a conventional drill string with a 17.5-inch bit and 36-inch hole opener assembly. This hole would then be re-drilled to a depth of 55 feet with a 10-foot bit on a modified 13 3/8-inch casing string. During this and the next 2 stages, drill cuttings would be cleared using an airlift system. Air injected through a 4-inch pipe inside the 13 3/8-inch casing would aerate the inner water column, reducing head and permitting the cuttings to rise through the center of the bit to the dump sub. Once the 10-foot hole was completed, the same bit assembly would be fitted with specially designed extension arms and the hole reamed to 20 feet, to the same depth, 55 feet. Additional extenders would then be welded to the 20-foot frame to ream the hole to 26 feet. After the hole was cleaned out, the bottom would be leveled with 4,000 cubic feet of cement to provide a solid, level base for the caisson. The caisson, a 45-foot-high hexagonal structure, would be lowered into the hole to rest on the cement pad with its lip projecting 5 feet above the sea floor. The sides of the hole would be cemented, and the caisson would be ready to house a standard production wellhead system, the top of which would be encased 20 feet below the sea floor, safe from iceberg scouring. February 14th. Offloading of the Ostend began. The ship's passage from St. John's had been very rough, and the seas were still running 10 to 15 feet. The tool pusher supervising the operation, the crane operator, and the deckhands on the supply boat had their work cut out for them that day. The slightest miscalculation would send a unit such as the compressor smashing into the rails of the ship or the side of the rig. With daily rig charter costs at $80,000, the delay that such an accident would cause might jeopardize the success of the entire project. With the equipment safely on board, the rig was ready to be brought into position and fixed. One or two of the rig's anchors had begun to slip, so the decision was made to replace them with Bruce anchors before drilling began. The service boats, on standby off the rig, were called in and anchors lowered onto their decks. Then each anchor was run out about 3,000 feet from the rig. In the rig control room, the barge engineer increased anchor tension to 350,000 pounds before slacking it off to an operational 200,000 pounds. Next, using satellite navigation, the rig was brought into position over the drill location, allowing only a 25-foot margin of error. Everything was now ready for drilling. A diamond core bit was connected to the drill string, since a core sample would be required before the pilot hole could be drilled. And on the second attempt, the bit brought up 7 feet of silty sand, which was emptied out onto the drill floor for analysis. Meanwhile, on the spider deck, work had begun on rigging the 10-foot bit. Large cutters, each weighing hundreds of pounds, were installed carefully in the bit body, which itself weighed over 8 tons. Both bit and cutters had originally been designed for hard rock drilling. As the men worked on the bit, 3 pilot holes were being drilled with the 36-inch hole opener using the conventional drilling system. The rigging took 44 hours. When the cutters were fitted into place, the connecting pins were driven home. Final adjustments were made, and all of the connections greased. With the pin-holding keys inserted, the bit was ready. Above decks, visibility was good. The Sedco 709, 3 miles away, could be seen drilling another step-out well, Hibernia 035. But the seas were running too high to offload the caisson from the Ravenstern, and the supply vessel had to stand by overnight. By morning, the seas had subsided enough to allow the transfer to begin. Slowly, with great care, the first giant section was lifted off the Ravenstern's deck. It was essential that swing be kept to a minimum, for each section weighed 30 tons. On board the rig, all other operations stopped. Under ideal weather conditions, the transfer of the sections from the supply boat to the rig would have been a critical operation. With 10-foot waves heaving the supply boat, it was extremely dangerous as well. As each section was lowered onto the rig's deck on the starboard side, the watchstander in the control room adjusted the rig's ballasting to maintain level balance. As the final section was slowly winched to the stern of the supply boat, the winds began to gather force. Much higher, and this operation would have to be suspended, causing a further costly delay. There was little time to spare as the last section lifted off the ship's deck and, barely clearing the rails, began its ascent to the deck of the rig. The caisson had been built at Marystown, Newfoundland at a cost of $120,000. Once the 26-foot hole had been successfully drilled, These 3 caisson sections would be welded together and lowered into the hole to rest on the cement base that would have been laid. Then the entire caisson would be cemented into the hole with a lip projecting a little above the seafloor. Into this housing would be inserted the production well head, protected from ice scouring 20 feet below the floor of the ocean. With the caisson section safely stowed, work resumed on the spider deck below. Slowly, carefully, the 10-foot bit was swung over the moon pool opening, where it hung, suspended from the bridge crane. The seas remained high. The safety boat circled close by, a precaution taken whenever there was activity around the moon pool. The 13 3/8 inch Kelly was lifted to the drill floor. 54 feet in length, it weighed over 6,000 pounds. Below on the spider deck, a specially designed crossover flange, which would transmit the rotary force from the drill string to the 10-foot bit, was raised into position above the bit, with its top extending through the floor of the drill deck above. The traveling blocks supporting the modified 13 3/8 inch N80 casing drill string was brought down. The driller locked the brake, and it was fitted to the top of the crossover flange. The entire assembly, consisting of the Kelly, the drill string, and the crossover flange, was lowered to meet the bit, and the bottom of the crossover flange was fitted precisely to the top of the bit. The 2 units were bolted together and the bolts tightened. Clips were then welded over them to give added strength. It was February 20th. Rigging had taken 3 days with some delay for bringing the caisson on board and because of weather. The airlift system compressors were checked out, with one large compressor boosting the output of 2 smaller units from 100 to 200 psi. A total airflow capacity of 2,000 cubic feet per minute would clear the drill cuttings. Tension was high as the 80-ton drilling assembly began its slow descent to the sea floor. Over the past few months, the mobile group and engineers at SEDCO, to whom specialized engineering services had been contracted, had carefully worked out theories and designed equipment. It was now to be put to the test in one of the toughest working environments on Earth. The start of the hole was monitored by a television camera positioned on the bottom. As the rotary table turned, the Kelly bushings were constantly greased. In 8.5 hours, the 10-foot level was reached. But the amount of cuttings being returned to the dump sub indicated that there was a blockage somewhere in the system. And before long, clogging had become so severe that the decision was made to pull the bit for inspection. Taking advantage of the delay, 2 divers were sent down to observe the hole as it had been drilled so far. This was the first of 4 dives that would be made during the project. As the diving bell descended, the safety boat stood by. The trip out was proving to be exceptionally difficult. The drill string joints had over-torqued, and heat had to be applied to break them out. Normally, the joints can be broken out using only the tongs. And what was a tough enough job to begin with was made even tougher by the heaving of the rig in heavy seas. A moment's hesitation, a single careless move, and a serious injury could result. With dogged patience, the work went on as stand after stand of casing was tripped out, the joints broken, and the sections racked to one side. After 11 hours, the bit finally reached the spider deck. Careful inspection revealed that the cutters themselves showed no real signs of wear. But there was a serious problem with the airlift clearance system, and rocks larger than the 4-inch size, which could not pass through the protecting screen, were clogging the bit. With the airline inside the drill string, there was no space for anything larger than 4 inches to pass. If the internal line were removed and an injection system fitted to the outside of the casing, rocks as large as 6 inches could be cleared. The decision was made to make the necessary modifications, and the hosing that was needed was flown out from St. John's. Within 36 hours, the modifications were made. Rubber hoses were connected to the 2 inlets fitted to the outside of the drill string 25 feet above the bit. And as the assembly was lowered, they were tied to the drill pipe with ropes at 10-foot intervals. The second problem that had been discovered during drilling was that the Kelly was binding in the drive bushings, causing the rotary table to lift. The solution was to weld bushing drive rollers to the rotary table. With both modifications completed, drilling could be resumed. Over the next few days, there were to be further problems. Damage to an intake manifold discovered through television monitoring made another trip out for repair necessary. Despite this, steady progress was made. Within the rotary table, the Kelly moved freely on the new bushing rollers. While at the dump sub, both the volume of output and the size of the cuttings being cleared had increased dramatically. And by the 2nd of March, the 10-foot hole had been drilled to the target depth of 55 feet and been thoroughly cleaned. Once again, the bit was brought to the spider deck, this time to be fitted with extension arms to ream the hole to 20 feet. The first stage of this assembly was to attach a stinger to the bottom of the bit. Through the bottom of this stinger, the cuttings would be drawn through the screen and up to the dump sub. The stinger was carefully fitted into the bottom of the 10-foot bit and securely welded into place. Then the 20-foot extension frame was moved onto the deck. Shaped like a pyramid that would be inverted to fit over the bit, the frame was awkward to handle in the restricted space of the spider deck. To provide room to maneuver it into place, the bit with the stinger attached was hoisted as far as possible out of the way. And the frame was swung into position beneath it, over the moon pool. No one had expected that mounting the extension frame would be an easy job. But the weather once again turned against them, and the rig began to heave. With the assembly swinging above the moon pool, the entire operation became more hazardous and difficult than had been anticipated. With great care, the stinger and bit assembly was slowly lowered into the frame of the extension arms. As thread would be inserted into the eye of a needle, so the stinger entered the hole at the bottom of the frame. And it was a great relief to everyone when the tons of swinging steel were finally fitted into place and welded together. White paint was applied to the bit and the frame so that observation of the assembly at the seafloor level through the television monitoring system would be improved. Everything was now ready for the next stage of drilling, and the descent began. The 2-inch steel pipes of the air injection system required no modification, for they had been installed high enough above the bit to allow for the extension frame. Of course, the air hoses had to be retied and restrapped to the drill casing as before. The bottom finally reached, the drilling assembly began to turn, and the 20-foot extended bit began to bite into the ocean floor. At the 16-foot level, a harder formation was encountered. The extension frame was strengthened, and a total depth of 28 feet was reached before penetration finally stopped. A serious problem had developed. Cuttings reamed at the top of the hole had fallen into the center, beneath the suction of the stinger, and had piled up at the bottom of the hole to the point that they were now beginning to clog the intakes. Once again, the bit was brought to the spider deck to determine what further modifications could be made. 25 days of rig time had now been used. The cost of the entire operation was approximately $5 million. To make the necessary modifications, much more expenditure would be required, and there was no guarantee that still new problems, leading to even more costly modification, would not be encountered. And so the decision was made to terminate the project. But the concepts had not been abandoned, nor was the project considered a failure. While it was true that the ultimate objectives had not been achieved, much had been learned that could be applied to subsequent research and development. The project proved that a 10-foot hole can be drilled to the depth of 55 feet below the seabed. Unfortunately, the system devised to ream that 10-foot hole to a width of 20 feet had not been adequate. New designs would have to be found, new concepts tested. Successes, failures, knowledge gained from mistakes, new beginnings, confidence that solutions to problems will ultimately be found. All are part of the ongoing saga of the development of oil resources that may lie beneath the iceberg-frequented waters of the North Atlantic Ocean.